you see how it's shrunk down? That would probably still work, but I want to make sure I have enough room in case the cylinder is a little off center. Now, as you can see, there are points that it says that it's going to be taking. In these gaps here, that is empty space. So I'm actually going to get rid of those and input a movement to go around it. So to do that, I'm going to start at the beginning of it. You can see where it transitions. That is the start of the program. So this is going to be point 1 right here. And then, so this is going to be my first point. It's going to go around, go up to the second level, and then end here. So it's good that I moved my probe back into the right, so that way I'll have a clear path to this point. The one I want to get rid of is the one above it. So that is where it transitions in the z-axis, x, y, z. It's going to go from 3.45 here to 2.9 right here. So I'm actually going to open that up and write down my x, y, and z coordinate. So then I can input a movement at the same coordinate. I'm just going to move it out a little bit further in z so I can actually move around, and you'll actually see that when I do that. So I'm going to put a movement, absolute, x, I'm going to change it to 1.75, y0, z, negative 2.95. I'm going to be at 0, 15, 180. Okay. And then it created a point right here. So I'm going to move that up to go right in between where it transitions. Now you can see that point right here. And I'm going to delete the actual point. And now there's just movement. As you can see, actually that's a little bit too close, so I'm going to change that to go a little bit further out in X. Let's make that 2. There, now we'll go around that gap. And I'm going to do the same thing on the other side. And it's at the same Z height, but it is at the other Y0. So right here, you can see the little indicator turned yellow when I clicked on it. So I'm going to create another movement, absolute, part coordinate system. This X is going to be negative 2, and the same Y and Z. And now my head orientation is not going to be 0, it's going to be 180, 15-degree probe angle, and 180 for the Z2 constant. I feel like now I need to put that right here. I forgot my X is offset because the pin was offset, so I actually need to make that go out further. We'll call that negative 3.5 and see how that looks. I changed the wrong number. This is supposed to be negative 2.95. I'm supposed to change the X, not the, let's try 2.5 here for the X. That's the nice thing about the simulation. Over here, you can actually see where you're putting it. Okay, so that looks a lot better. Now I'm going to delete the actual point. And now you can see my point in space here where it's going to go around this. All right. We're also going to input a tolerance for that diameter, since that is a measured feature. Where's the code drawing? Okay, that is supposed to be 4.319. Oh no, that's over the pins. So 3.934. And that's plus or minus. Create a new tolerance by double clicking in your tolerance zone, either one of these. New, name it, flange OD. And this is going to be plus or minus 3 thousandths. Okay. Okay, and cross your fingers. Normally, I'll also slow the speed override on the controller down. Click apply, it'll warn you it's about to go into automatic mode. Click OK. So far, so good. Now that we have that OD, we can continue on with our datum structure. So go to datums. We're going to go to 2 axes. Same pop-up window, just different checkbox. We're going to leave A as our top surface, or we're going to leave, well, top surface still for this one, and our secondary is going to be, I'm going to name it datum B because the flanges, I'm going to use that to simulate datum A actually. Datum A. You know what? I will swap these. Datum underscore A is going to be my flange OD. My X and Y origin. Secondary is now going to be my top surface. Turn off the axis for your secondary. If there's any conflict, you really want to go with the primary. They should be the same, but not always. Origin for the secondary is going to be Z. Click OK. You should see a slight shift in the model to compensate for the actual physical part. Tertiary axis is not specified. That just means that somehow this became unchecked. Click disable there on tertiary. Okay. And now it is located the part. Now we also need to find the part's rotational orientation. So I'm going to do another absolute movement. Actually, considering my current location, I do want to just go to the previous location that I had up here, which is in that corner above the part. So I'm going to right click, copy, paste, double click there, and step. And now I'm going to go to the middle of the part. I'm going to use the slot, this side right here, as my rotational feature. So I'm going to do another absolute movement. I just want to go into the center of the part now. X and Y 0. And stay above the part. ½ inch. part coordinate system, you can leave that whatever orientation, as long as it's straight up and down. Your Y is 0. Okay, moving to it. And then I'm just going to measure that as a plane. So go to inspect, plane, select that surface. I'm just name that something to identify it. So I'm going to call that slot X plus wall. I want that to also be just CMM movements. So orientation none, touch CMM. I don't want it to rotate, I don't want it to flick. And then I'll just take 4 points. You can take any number of points. A plane requires a minimum of 3 points. Actually, I'm going to take, let's take 6. And then apply. Now I'm going to use that as a rotational datum. It's not an actual datum, it's just for locating the part. So under the datum drop menu, I'm going to go to rotate to feature. The feature I just created, which is the slot X plus wall, that wall is actually facing X minus. So I want it to align to X minus. Okay. And you saw the model just shifted slightly. And now we have completely located the part physically. Save. Go back above actually even from where I'm at now, I can start measuring the rest of the walls of the slot. So on this side here, I'm going to treat these two surfaces as one surface for that slot width. So I'm going to select the plane again. I'm only going to select this plane this time. I'm not going to do multiple geometry, but I'm still going to take points on both surfaces. And again, I'm going to do regular CMM touches. Call this one slot X minus wall. So that way I can match it, I compare it with the X plus wall. And then take a few touches off each of these. My probe is already here, so I'm actually going to take my first points on this side. So I'll take a point here, here, here. All right. And then I'm going to apply. And it's going to measure those surfaces. I have those two planes now. You can see right here and here. I'm going to measure the distance between them to get my slot width. So I'm going to go to output, distance between, and I'm going to select those two features, my slot X plus wall and my X minus wall. And I'm going to go to new. I'm going to name that slot width. And I believe both slot widths are the same. So I'm just going to call it 500 for 500 thousandths, just something to describe it. The distance should be, they want a nominal feature, so I'm going to give them 5.005 with a high of 5/10 and a low of -5/10. Click OK.